Have you ever looked up at the night sky and wondered, are we truly alone in the universe? That question, one of the oldest and most profound we've ever asked, might finally have an answer. Thanks to the incredible power of the James Webb Space Telescope, we may have just caught the scent of life beyond Earth. And not just any sign. Something truly extraordinary has been spotted on a planet called K2-18b. So buckle up, because this might just be one of the most important discoveries in human history. So let's start with the headline. Scientists using the James Webb Space Telescope detected a molecule in the atmosphere of K2-18b called dimethyl sulfide. Now, on Earth, dimethyl sulfide is a big deal because it's almost exclusively produced by living organisms, specifically tiny ocean-dwelling creatures called phytoplankton. That's right, we're talking about microbial sea life. So when astronomers saw signs of dimethyl sulfide in the atmosphere of a planet 124 light years away, jaws hit the floor. But that's just the beginning. Alongside dimethyl sulfide, researchers have also found dimethyl disulfide and large amounts of methane and carbon dioxide, a chemical cocktail that, on Earth at least, is heavily associated with biological processes. Even more mind-blowing, the concentrations of these biosignatures weren't just similar to Earth's, they were thousands of times higher. That's not a faint whisper of life, that's a roar. And you might be wondering, we found methane before, so why is this different? The answer lies in the uniqueness of dimethyl sulfide. Unlike methane or oxygen, which can be created through geological or other non-living processes, dimethyl sulfide is much harder to explain without biology. Here on Earth, it's only made by life, period. It forms when microorganisms break down DMSP, which is basically a molecule involved in their metabolic processes. So when we detect dimethyl sulfide in Earth's air, we're literally smelling the breath of marine life. The fact that the James Webb Space Telescope found something like this on another world, that's potentially historic. Let's just take a moment to appreciate how this was even possible. The James Webb Space Telescope is the most advanced observatory humanity has ever built. Using instruments like its near-infrared spectrograph and mid-infrared instrument, the James Webb Space Telescope can study the light from distant stars and planets with surgical precision. And here's how it worked. As K2-18b passed in front of its host star, some of the starlight filtered through the planet's atmosphere. Different molecules absorb different wavelengths of light, leaving behind a kind of barcode, a spectral fingerprint. The James Webb Space Telescope decoded that fingerprint, and what it found was astonishing. But, as many good scientists will tell you, extraordinary claims require extraordinary evidence. So the team behind the discovery went right back, again and again, checking and rechecking the data. And what they found held up. And right now, these detections sit at a 3 sigma confidence level. That means that there's only a 0.3% chance that this is just random noise or a mistake. Impressive? Absolutely. But not yet conclusive. In science, a 5 sigma detection, just a 1 in 3.5 million chance of error, is the gold standard. That's the level where scientists start popping champagne. So we're not quite there yet, but we're close. Closer than we've ever been. K2-18b isn't just a random planet. It's located in the habitable zone of its star, meaning it's at just the right distance to potentially host liquid water, the elixir of life as we know it. Even more intriguing, K2-18b is what scientists call a Hycean world, a planet with a hydrogen-rich atmosphere and possibly a global ocean beneath it. Conditions that some researchers believe could be ideal for nurturing life. And this isn't some bizarre outlier of a world. K2-18b belongs to a class of planets that we now think are common across the galaxy. And if life can thrive there, it could be everywhere. Let's imagine for a second what life might actually look like on this alien world. K2-18b is about 2.6 times Earth's radius and nearly 9 times its mass. That means its gravity is intense. Any organisms living there would need to be adapted to crushing pressures and a thick, hydrogen-rich atmosphere. But as we've seen on Earth, life is incredibly adaptable. We have extremophiles, which is just microbes that live in boiling vents, acidic pools, and even radioactive waste. If Earth's life can survive that, who knows what could evolve on a planet like K2-18b? Maybe life there doesn't photosynthesize like plants. Maybe it uses hydrogen and carbon dioxide in exotic metabolic reactions. Maybe dimethyl sulfide is just its version of burping. And remember, these signatures aren't faint. The dimethyl sulfide levels are thousands of times what we see in Earth's oceans. That could point to a whole biosphere, a massive thriving ecosystem beneath those alien clouds. So far, most scientists think the first alien life we'll find will be microbial, tiny, single-celled organisms. But the strength of these biosignatures has led some to wonder, could there be more? Could K2-18b support multicellular life? Creatures that float, swim, or even glow in the dark ocean? Maybe they have bladders to control their depth, or colonies that float near the atmosphere-ocean boundary to harvest chemical energy. On Earth, complex life took billions of years, but who's to say it couldn't happen faster anywhere else? Evolution follows different paths under different pressures. On K2-18b, it might have taken a whole other route, one we can't even imagine. For decades, we looked for Earth 2.0, rocky planets just like ours orbiting sun-like stars. But K2-18b challenges that assumption. It suggests that life might flourish in places we once considered hostile. Hycean worlds with their thick atmospheres and deep oceans might actually be better for life than Earth-like planets. They're more stable, they're more protected from radiation, and they seem to be everywhere. If K2-18b has life, that means that the universe might be full of it. Not just a rare occurrence, but something that happens often when conditions are right. Now let's zoom out. If we confirm life on K2-18b, we'd have a second genesis, a second independent origin of biology. And that really does change everything. It turns astrobiology from a field based on speculation into one based on comparison. We could start to define universal features of life, not just what works on Earth. And if life emerged on a planet just 124 light years away, what are the odds that we're the only ones? The Drake equation, which estimates the number of civilizations in the galaxy, suddenly looks a lot more optimistic. Scientists believe that there are around 40 billion Earth-like planets in the Milky Way. And if even a fraction of those host life, then the galaxy could be teeming with alien ecosystems. Some microbial, some maybe even intelligent. To move from maybe to definitely, scientists do need more data. And the James Webb Space Telescope team is planning further observations to reach the coveted 5 sigma threshold. And it won't stop there. Future missions like the Habitable Worlds Observatory will peer even deeper into alien atmospheres. They might detect not just biosignatures, but the specific processes driving them. We'll also start targeting other Hycean worlds, now that we know how promising they might be. Each new observation brings us closer to a fuller picture of life in the universe. And if all this holds up, this discovery could be the moment that changed humanity forever. Just as Copernicus showed we're not the center of the solar system, and Darwin revealed our deep connection to all Earth life, the confirmation of life on K2-18b would show that we're not alone. And maybe never were. It would force us to rethink our place in the cosmos. Not as a lonely accident, but as part of a grand, repeating story written across the stars. So what do you think? If we dove into the oceans of K2-18b, what might we find? Let me know your thoughts in the comments. I want to hear your wildest theories. And of course, please like this video and hit that subscribe button because we're only just beginning to discover what's out there. Thanks for watching and we'll see you on the next one.